All right, so we're doing additional topic number 5, projectile motion. So this should be a pretty easy section for us because we've discussed acceleration, velocity, position many times before. Basically, you can start with the position function, differentiate to get v of t, differentiate again to get a of t. Likewise, you can integrate from acceleration to get velocity, from velocity to get position. Okay, so in many real-life problems, we will be using the same acceleration. It's the acceleration gravity, right? If we're using meters and seconds, gravity is negative 9.8 meters per second squared. So you might want to underline that so you can find it easily. And if you're using feet and seconds, we're going to use gravity as negative 32 feet per second squared. In these examples, we're going to ignore air resistance, although air resistance would be very important, especially in number 4 when we're shooting a human cannonball and we want to know where to put a pillow, right? That would be bad. All right, so number 1. So if a diving platform is 20 feet above the surface of the water, okay, so we have our water down here. We have some kind of platform above the water. All right, and this is 20 feet, we said. And a diver starts with initial velocity of 6 feet per second in the upward direction. So he's going to go up 6 feet per second. What is the diver's velocity at impact? So he's going to come back down. We want to know what his velocity as he hits the water is. Okay, so you need to make a couple choices in here. You can decide for this to be a height of 0, the water, or you can decide for this to be the height of 0. So in other words, he'd be going negative 20 down. It doesn't matter, whichever one you want. I usually let it be the place where he started, so S of 0 is equal to 0. He or she, I guess. So that means after a certain amount of time, we don't know how long, so I'm going to put question mark. He's going to be at negative 20. Yeah, we'll say it's Mr. Napier. He was a diver. All right, so we start with what we know. We don't really know much in this problem, but we do always think about acceleration. Acceleration, it's in feet and seconds, so we should use negative 32 feet per second squared. It's negative because gravity's pulling you downwards. All right, your velocity then, we integrate. Now you don't have to do the integration signs or anything. You just integrate. You get negative 32 t plus c. What is c always going to be in this problem? No. It's not 0. C is always going to be what we call our initial velocity. Does that make sense? Because if you plug in 0 for t, you get, at time 0, what the velocity was. So in our case, initial velocity was 6, and it was in the upward direction, so it's positive 6. So c ends up being 6. So negative 32t plus 6. All right, then we integrate again to get the position function. So our position function is going to be negative 16t squared plus 6t plus some new variable, or some new constant, d. All right, what's d in this case?
I want to make it 20.
This is your initial height. Evan says he wants to make it 20, but remember I said this was going to be 0. We assigned it to be 0. So like I said, that's kind of a choice up to you in the problem. It could be 20 or it could be 0, depending on how you made the other thing, the S of question mark as I wrote it. Okay, so we want to know what is the diver's velocity at impact. So in order to find that, we first need to find something else. What do I need to find?
Time of impact.
Yeah, we need to find what time we hit the water. Is that what you're going to say, Kinsey?
Yeah.
All right, so we need to find the time. So in order to do that, we want to find, so let's say when you hit the water. So we're plugging in 0 for our position function. So I have 0 equals negative 16. Oh, nope, not 0. Negative 20, right? Negative 20 equals negative 16t squared plus 6t. So basically, I'm just going to graph y1 to be negative 16t squared plus 6t plus 20. And I'm going to solve. Hit graph. Find the 0. We want to find when it's crossing the x-axis. Time is not going to be negative, right? So we're going to find the positive value. When you do this, you should get t equals 1.321, somewhere around there. So I have 11473 on my screen when I found the 0. All right, this is in seconds. I want to save that value, so I'm going to exit out of my graph page. I'm going to hit X, and I'm going to store that X value as, let's call it A. So that way I'll have that stored in case I need it, which I know I will, right? So that's the time that you hit the water. We want to know the velocity at impact. So the next thing we do is we take that time and we plug it in for the velocity equation. So we plug in A. So it's negative 32 times whatever A was, plus 6. And what'd you guys get? Negative 36 is what we said? Negative 36.277 feet per second. It's velocity, so it's feet per second. Okay. Now be really careful. On your AP test, it's tricky sometimes. So it probably wouldn't do something like an example like this, but it might say something like state the velocity and the direction. Okay, if you're stating the velocity and the direction, or state, I don't know, you probably want to say like 36.277 feet per second in the downward direction. Does that make sense? You do not want to say negative 36.277 feet per second down. It's kind of like a double negative, right? It's like, what do they mean by this? So be kind of careful, especially with speed. Speed we know is always positive. So if they ask for what the speed was of the diver, it would be 36.277 feet per second. Tim, you paying attention? All right, so I told you we're going to skip number 2 for now because I left out an important piece of information on number 2, so we'll go back and edit it. So let's go to number 3. So let's look at number 3.
We finally got to the Michael Jordan problem.
Have you seen that picture forever? All right, so it's been reported that basketball star Michael Jordan has a vertical leap of 54 inches. Ignoring air resistance, what is the initial velocity required to jump this high? So that's pretty tall. So 54 inches. What is that in feet? 6 feet? That'd be 72. All right, so let's figure it out. 54 divided by 12. 4.5. 4.5.
12. 60 inches is 5 feet. Yeah.
5 feet.
60 is 12.
All right, 4.5 feet is pretty high. 6 feet's a lot higher, but 4.5 is pretty high. So imagine 4.5 feet. So that's probably, I don't know, like up close to my shoulder. So he could jump like this high. It's pretty
That's
crazy.
like where his feet are?
Yeah, that's where his feet are.
That's ridiculous.
Okay, and that's just a vertical leap. I think that's not even with a running jump. It's just straight up and down. Like, kind of crazy. Okay, anyway, so what do we know that we can use in this problem?
Well, you have the deceleration.
Yeah, we know how much the gravity is, right? So our gravity in feet per second is negative 32 feet per second squared. Okay, now our velocity then is going to be negative 32t plus some initial velocity. That's what we're trying to find. So that's the initial velocity. All right. So let's go ahead and get position. So negative 30 or negative 16 t squared plus c times t plus, what's my d value? 0, because he's starting from the ground. Okay, so I have my three equations. Okay, we want to talk about that exact moment when he's 4.5 feet in the air. Height, when he's 4.5 feet high. What do we know at that point? Velocity is equal to 0. Okay, that's the key. The velocity is equal to 0 because he's now reached the highest point and now he's coming down. It's kind of like in those cartoons, you always see like the cartoon character pause in the air and then drop. You know, it's kind of like that. Okay, so the velocity is equal to 0. So this is going to give us two equations from the 4.5 feet high and the velocity equals 0. So 4.5 is our position. So 4.5 equals negative 16 t squared plus c times t. And from the position, or from the velocity, we get 0 equals negative 32t plus c. Are we able to solve for c? Mm-hmm. Yeah, because this is now a system of equations. We have two equations and two variables. So we can solve. Tim, stop. All right, so you're going to solve for c. So you get c equals 32t. And you're going to take that c value and you're going to replace it in the other equation. So you're going to get 4.5 equals negative 16t squared plus 32t times t. In other words, 32t squared. So you have 32t squared minus 16t squared, so 16t squared. So this is kind of tricky because I think you guys might have had a little bit of trouble coming up with the two equations. So always think about all the different things you know. You know acceleration, you know at that point when he's 4.5 feet high in the air, his velocity is 0. You know all these different things, so think how they're related to acceleration, velocity, and position, right? Okay, so let's solve for t. So do 4.5 divided by 16, and then we're going to take the square root. Time's always positive, so it's just 0.53033, and so on. You can store this if you think you're going to use it again. So let's store as b. Store it as anything. Can you what?
Is it okay if we just go 3 decimals backwards?
It will be important that you store because remember when we've rounded before early, sometimes you're off by like 40 units, right? It makes a difference. Okay, you could just use answer though, the answer key. All right, now if we want to find c, well c is just 32 times t. So c is going to be 32 times 0.53033, whatever we had in our calculator. So 32 times b. Yep, 16.971. And c was a velocity, right? So it's feet per second. Good. Pretty fast. All right, so let's try number 4. Okay, so human cannonball is launched at an angle of 30 degrees from the horizontal. So I'm going to kind of put this one on an axis. So I'm going to start at the origin. You're going to fire up kind of in a straight line initially. But what it does is it creates a parabola. Because you have gravity pulling downwards, it's going to create a parabola. Okay, those of you that have taken physics will think these are super easy. Those of you that are not in physics might have a little bit of a hard time at first, but it's fine. It won't be bad. All right, notice how I said initial speed is 49 meters per second. Think about that. So this person is being fired from a cannonball at 49 feet per second. Now, it's not 49 feet, or meters per second, I guess. It's not 49 meters per second straight in the air, right? So you kind of have like a vertical component and a horizontal component. We don't know how fast he's going straight up and how fast he's going straight over. Okay, so we need to find those. So you create a little triangle. So the hypotenuse of this is 49 meters per second. and you're going at a 30-degree angle. So we have 30 degrees in there. I'm going to call this my Vy and this my Vx. So that means my vertical velocity Vy, so my velocity in the y, along the y-axis kind of, up and down, and my horizontal velocity. So basically he's going out a certain speed this way and a certain speed up, and we need to find those speeds. Okay, so let's say initial velocities. Okay, so Vy, think about it. If I'm solving for Vy, you have 30 degrees and you have 49. You have a right triangle. Use your SOHCAHTOA. How do you set up an equation with Vy?
Sine.
Yeah, it's sine of 30 degrees equals opposite, so Vy, over hypotenuse, 49. So Vy ends up being 49 times sine of theta. I just always remembered sine values are my y values. So take my initial speed, 49, and multiply by sine of 30, whatever your degrees was. All right, so that means Vx is probably going to be 49 cosine of 30, because like I said, I remember x was cosine then. So if you check, cosine is, so you'd have cosine of 30 equals adjacent, so Vx, over hypotenuse, 49. So that's how we got that. So those are my initial velocities. Okay, so we're going to talk about the vertical components. Okay, so basically my vertical initial velocity is 49 sine of 30. What's my acceleration? Yeah, negative 9.8. So I have the acceleration, I have gravity pulling me downwards, right? In the vertical direction, so negative 9.8. So that means if I'm coming up with v of t, it's negative 9.8 t plus my initial velocity, 49 sine of theta, or sine of 30 degrees. In the other class, I had them write v sub y sub o. So it's like the initial velocity in the y direction. Does that make sense? But you don't have to do that. Okay, so that's v of t. S of t would then be negative 4.9 t squared plus, well, let's find what 49 sine of 30 is. Remember, sine of 30 degrees, you go up here, it's 1/2, so it's 24.5, because sine of 30 is 24, or sine of 30 is 1/2. So it's 49 times 1/2. So I have so negative 9.8 t plus 24.5 for my velocity. So when I integrate, I get negative 4.9 t squared plus 24.5 t plus, what's d? 0, because that's why I started it over here as 0, 0. Okay. So the question is, determine the time of the flight and find how far away the cushion should be placed on the ground. So the cushion thing is a horizontal component. So let's talk about the horizontal. On this, v of x is 49 cosine of 30 degrees, which ends up being 49 times square root of 3 over 2. So it's like 42.435. What's the acceleration? Exactly, it's 0. So acceleration of negative 9.8 was in the vertical direction. There's nothing pulling you faster or slower in the horizontal direction. Okay, so there's nothing for the acceleration. Exactly, we're ignoring air, remember? So a of 0 equals 0. Yeah, when you do air resistance, have you guys done that in physics? Yeah, it's insane, isn't it? The equations. Yeah, aren't they like really?
They're awful.
Yeah. That's why you usually ignore them in math class. I don't know why. Okay. So, v of t. So its velocity function is going to be a of 0 times, or so a was 0, so 0t plus c. So in this case, it's 42.435. That's the initial velocity. And s of t is going to be 42.435 t plus d. What's d in this case? 0. You started at 0, 0. So x was 0 as well at the initial. Okay, so time of flight. What do we need to find for time of flight? Yeah, we want the vertical position to equal 0, right? So we want negative 4.9 t squared plus 24.5 t to equal 0. It works out very nicely. T ends up being 5. You can pull out the common factors and all that. T is 5. All right, so 5 seconds is the first answer. Okay, the second thing we ask is, where should the cushion be? So the cushion, what do I need to do for that? Yep, plug in 5. So do 42.435 times 5. We plug it in for the position for the x values, right? You take your answer, multiply by 5. You get 212.176 meters. Hopefully you have a very, very large cushion if you're ignoring air resistance. So it can be approximate. All right, so let's go back to number 2. So I'm going to do some edits on number 2. Okay, we decided that the golf ball being hit at 16 feet per second was not good. It's like putting. So we'll make it 120 feet per second at 15 degrees. So an angle of 15 degrees with the horizontal. Okay, we're going to find an equation for the height of the ball at any time t. We're going to determine the maximum height, the amount of time the ball spends in the air. Also find the horizontal distance the ball has traveled. Okay, so we're going to set this up exactly like the last one. Do you guys want a couple seconds to try it? Yeah, so I'll let you guys try it to start out with. Okay, so are you guys coming up with some good equations?
Yeah.
Okay, that's a weird problem. Okay, so first you need to come up with the vertical and horizontal initial velocities. So you have 15 degrees. It's not going to work out as nice as 30 degrees since that was something on our unit circle, right? Okay, so we have the horizontal initial velocity would be cosine of 15 degrees times the 120 feet per second. And our vertical would be sine of 15 degrees times the 120 feet per second. Make sure you're in degrees, right, on your calculator. So you get 115.9110992 is what my calculator says. So I'm going to store that as A. And then the other one is 31.058285541. I'm going to store that as B. Okay, so when we talk about the vertical components, you know your acceleration is negative, are we in feet per second? So negative 32 feet per second squared. Your velocity is going to be negative 32t plus the initial velocity of, what did we say it was, b. So we stored that, so maybe I'll circle it so you know that's a stored value. And then our position is negative 16t squared plus b times t plus, we're starting at 0, 0. So we're going to say 0. You with me that far? Okay, some things we asked about the vertical components is we said, determine the maximum height and the amount of time the ball spends in the air. Okay, so how would we find the maximum height? Yeah, vertical velocity is equal to 0, right? So when it gets to the top, it's going to kind of momentarily stop and then fall. All right, so I'm going to have negative 32t plus b equals 0. So I'm going to basically take my b value that I had and divide by 32. Okay, that gives you t equals 0.9707, oh no wait, 0.97057, somewhere around there. Let's store that one as c in case we need it. Then it said find the amount of time the ball spends in the air. So what would, oh, we need the maximum height, don't we? We didn't finish it. So that's just the t value. That's the number of seconds that it takes to reach the maximum height. So then we need to plug in that number in for our s function. So you're going to have negative 16 times our c value squared plus b times c. So what do you guys get for your max height? Yep, 15.072. Yep, and that's going to be in feet.
You don't want any acceleration.
You what?
You don't have any acceleration.
Because it falls going after that many seconds, you don't have acceleration.
I don't know what you're saying. So we don't have an acceleration?
There's no acceleration because you're just finding a distance. What?
There's the acceleration of gravity.
Gravity.
Yeah, gravity's pulling you down.
Deceleration.
Yeah. All right, so now if we want to find, so we found the max height, amount of time that the ball spends in the air. So how long would it be in the air for? Yeah, you can set the position equal to 0 and solve. What you could also do, since this is a parabola, if this was at t equals, what is it, 0.97057, just multiply by 2, right? You should get the same thing. So take the c value that we had and multiply by 2. So you should get t equals 1.941 seconds. Okay, and then the last thing we asked is the horizontal distance the ball has traveled. So we need our horizontal components. So our horizontal components, our acceleration is 0. Our velocity is going to be 0t plus our vx velocity, so it's going to be a. I'll circle it so that you know that's a stored value. And s is equal to a times t plus 0. Because the horizontal distance, or the horizontal place we started was 0, right? Okay, so find the horizontal distance the ball has traveled. If it was in the air for 1.941 seconds, it's just s of 1.941. So it's a times 1.941, which I still have in my calculator as the non-rounded form, so I multiply by a. What do you guys get? Comes out nice. 225, exactly. So 225 feet. Okay. Does that make sense?